that some of y'all, I think we took a survey, and I think like 4 or 5 of y'all, at 2 or 3 at each campus, or 1 or 2 at each campus, has never seen trig before. So we will act like that, you know, there's some of you that don't have it. We talked about a little bit like this last time. We talked about 360 degrees. Acute angle is less than 90. A right angle is 90. Obtuse angle is 180, and a straight angle is greater than 180. Well, no, greater than 90, less than 180, and a straight angle is 180. I'm not going to insult anybody's intelligence there. Complementary is equal to 90 degrees. We talked about that. That's 2 of the problems we did, except we did them with pi, with radians, and you can do it with degrees also. I'm not going to go over that. We already talked about that. This is about where we were getting last time. I don't use this because that, to me, is confusing to students. There's 60 seconds in a minute. There's 60 minutes in a degree. Okay? There's 360 degrees in a circle. All right? Now let's go ahead and start here. And this is where we left off. I want you to add or subtract these 2 numbers, or 2 angles. And again, one is regular, just add. And the other one, instead of using 90, you have to use, and we're not using calculators yet. Okay, I want y'all to be able to spell mom backwards and make a change. So you're going to change that 90 to 89, 59, 60. Or in this case, you don't need the 60, so you can make this 60. Why do I not need the 60 here? It's because we do not have what? We do not have any seconds, so we don't need the 60 seconds. We don't need that. So this one is going to be 89, 60. Okay. 89, 60 minus 73, 12. And this one is going to be 51, 29 plus 32, 46. And you should be able to get those without any problems. 9 plus 6 is 5. Bring your 1, 7, 3, and 8. 60 minus 12 is 48. And 89 minus 73 is what? 16? Y'all check me. This one is good because 16 degrees, 48 minutes. This one is not finished because you don't have 75 minutes in a degree. Think of it like 90 minutes. I think we talked about this a little bit last time. You don't say 90 minutes, you say an hour and what? A half. So in this case, this 60 minutes is a degree. So that 60 minutes, bump this up to what? 84, and that leaves 15 minutes here. So your final answer is 84, 15. Those are 2 test questions that you might see on the test, so make sure you know how to subtract or add degrees, minutes, and seconds. And I think that's where we left off. Questions on those? And of course, on your calculator, we'll get to that in just a minute. Decimal degrees. Okay? Now, which ones are used in the real world? This one is used in the real world. Let me take my handy dandy highlighter. That one is used in the real world. If you walk up to any architect or any civil engineer or any surveyor in the real world and walk up to them and say, I need to turn 34.817 degrees, they'll look at you like you're speaking Japanese. Okay? And I hope it's okay to say Japanese. That is a language. I hope I haven't offended anybody. All right? You do not walk up to somebody turning a theodolite or a transit or whatever and say, I need to turn 34.817 degrees. That ain't the way it happens. Okay? Anytime you're at a construction site or you're working with a surveyor or a civil engineer, you're going to turn 74 degrees, 8 minutes, 14 seconds. Why do they have decimal degrees? I have no idea. Okay? I have no idea. I guess to make calculations easier in academia. That's the only thing I know. All right? Now, how many degrees? Well, how do you change these? Well, and I'm just going to do it this way because it's a whole lot easier just to have printed out. That's how you change a degree, minutes, and seconds into degrees and a decimal. You put the first one over 60, and you put the second one over 3,600. Now, the reason you put it over 3,600 is because there's 60 seconds and 60 minutes. That's 60 times 60 is 3,600. That's how you do it. So that's an example of how you change a degree, minute, seconds term into decimal degrees. Would you do that in the real world? No. Never. But the next one you would do because nobody is going to turn 0.817 degrees. And that's where you have to divide each one, and go ahead and do that. You get 74.137 degrees. Now that is a good example of a question I might ask on a test. I'll ask one of each. So far you've got 4 questions on the test. And these are very basic. There's the one that you would have to do in the real world. Take an academia answer and change it into a real world answer. There is how you do it. You take the whole decimal and multiply by 60 minutes. Then whatever's left, you multiply by 60 seconds. So I took the 0.817, multiply by 60, and get 2 whole numbers out of that. And the 2 whole numbers are 49. Whatever decimal is left, you're going to multiply by another 60. Now, here's another real world application. Are you ever going to use 1.2 seconds? No. A theodolite or a transit is you only can go to a certain number, like a 1-minute transit. My father had a 1-minute transit, and it is in my house, and the closest you can get is 1 minute, and you have to use a magnifying glass to actually see the little hash marks. Whereas a theodolite is a computerized transit. A theodolite can turn up to 10 seconds. So are you ever going to use that 1.2? No. Now, for academia, you put 1.2. Real world, that would be 34 degrees, 49 minutes, 1 second. And even then, the theodolite cannot turn that 1 second. So you would just turn it above 0 just a little bit, because you only got 0. They do make 5-second transits now, but nobody uses them. They're too high. And you're not going to get any different between 5 seconds and 10 seconds. There's not that much of a difference unless you're putting in airstrips or highways. And then you would use, because you could see longer distances, and you would use the 5-second transit versus the 10-second transit. And some of y'all have no idea what I'm talking about. But that's what you do. Okay? Take the 0.18817, multiply by 60, and you'll get something like 4902, blah, blah, blah. And then you take the 0.02 and multiply that by 60. Okay, so now you got 4 questions on the Unit 1 test. Now let's go and pull up your calculator. Let's do that right quick because some of you may know how to do it. I don't know if you know how to do it or not. But, of course, again, some of you name your calculator and have a little bed for it at home and that stuff like that. I don't know. Take your handy-dandy calculator. Some of them use that calculator as a security blanket. And I think it's under math. I don't use it very often. Somebody tell me it's under numbers.
I think you hit second.
Second.
It's under apps.
Okay, thanks. Second apps, and you have the degrees and the minutes. I think I don't even know where apps is. Where's apps?
Pink one.
Pink
Like
one.
red.
Okay, thank you.
On mine it is.
Okay, maybe it's apps. Just apps. This is a newer. Let me get out of this. Damn brushes. There it is. You have the minutes and you have the degrees, but you don't have the seconds. Seconds is down here. There's a quotation mark. I can't see because I can't see the blue or the green on this screen. So I think it's over one of the, you'll see quotation marks. I'm looking, but I can't see.
Alpha and then the plus sign, I think.
Okay, alpha plus. Yeah, there it is. Green plus. Look above the plus symbol and you see the quotation marks. Okay? If you want to change it to degrees, minutes, and seconds, you use 4. If you want to change it to degrees, minutes, and seconds, it'll show you how, I mean, you can do it that way. But it's not that big of a deal, okay? The way you type in, you would say 90 degrees, 90 second apps, degrees, 24 minutes, second apps, okay, I'm about ready to give up, minutes, and 2 seconds, and you hit alpha plus. And it'll automatically change it into decimal degrees. Now, if I want to change it from decimal degrees, you hit the decimal degree function, which is right here. You type it in and change it to degrees, minutes, and seconds. So if I wanted to type in enter, there. Change the answer 90.40. I just used that answer. Or you would type in 90.658 and then degrees, minutes, and seconds. So that's how you use your calculator. Second, apps, and don't forget the alpha plus is your seconds. And that's how you use your calculator to do that. Now, if you wanted to subtract on your calculator, you would just do, it'd be a pain in rear, 90 apps, degrees. I'm not going to do the second. 34 second apps, degrees, minutes, minus 24 degrees and 15 minutes. And equals. Change it to what? Second, apps, degrees, minutes, seconds, and you feel good about yourself. 66:19. Now, being a land surveyor and growing up in land surveying, would I be prone to give you a lot of these questions of adding and subtracting angles? Yes, especially with bearings, and I will get into those. Okay. Next, and that shows you what I just went over there. Anybody got a question so far? Everybody good? Y'all settle down, Pendleton. All right, we talked about this a little bit, the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. And in the real world, it's the exact backwards opposite, okay? Northeast is 1, southeast is 2, southwest is 3, and northwest is 4. Why do they do it? I have no idea. But this is where your unit circle comes from. 0, 360. Remember me telling you 0 and 2 pi? Well, this is where your unit circle starts. This is where it originates. So, in the unit circle to trig is like X and Y is to algebra. If you don't learn the unit circle, then you might as well just go ahead and drop the class. All right? This is 0 radians and 2 pi radians. This is 90 degrees, or pi over 2. This is 180 degrees, or what? Pi. This is 270, or 3 pi over 2. And it keeps on going. Now, we're going to fill this thing out as we go. And this is 2 pi, or 0 pi. Okay? So, you need to know that quadrant. You need to know the quadrants, and believe you me, you're going to learn that unit circle before this unit's over. Again, I'm assuming that 4 or 5 of y'all haven't seen this before. That's why I'm trying to go slow here and try to make it as, trying to do, you're still writing, Mandy.
I'm
go
always
ahead.
writing.
Okay, well.
I know what I write it.
Okay, all right. Okay. I'm not going to go in this too much because it pretty much, all you have to do is divide by 360. If I gave you 830 degrees, now I'll go ahead and show you how to do this. You take 830 degrees and divide by 360. Somebody take your calculator and divide by 830 degrees. Divide that by what? 360. Tell me what that means. Tell me what you're going to get.
2.3.
Okay, 2.3. So you know that you have 2 revolutions in 830 degrees, right? So 2 revolutions would be 700 and what? 720. So somebody take 830 minus 720 and tell me what you get. 110. That's how you find your, it's called coterminal angles. If you got a lot of, take the 420. 420 divided by 360 is what? 1 point something. 420 divided by 360 is equal to 1. So you got 1 revolution. So subtract 1 revolution, and what do you get? 60 degrees. That's how you find. Now, are they always going to give you an easy one like 420 degrees? No. Will they give you one like 1630 degrees? Yes. So you take 1600 or whatever divided by 360 and get the rotations, multiply the rotations, time, whatever, 360 to get the number you subtract. Capiche? Not a test question, but you may see it on homework. So I'm going to do, okay, negative 75, we're going to cover these 3. All right, let's do this. So 908, somebody divide 908 by 360. 908 divided by 360 is what? 2.5. So you take 2 times 360 is what? 720? And you subtract 908 minus 720. What do you get? I'm sorry, what?
188.
188 is your reference angle. Negative 75. Well, be careful here because negative 75 is, this is the way it goes, right? So negative 75, I'm going to tell you another thing right here. This negative 75 would be in this direction. And negative 75 means that the black angle is what? Is 360 minus what? 75. What is it? 285 degrees. Now, here's the funny part. Remember me telling you that in the real world that you never use decimal degrees on site? 2, you never, or the quadrants are different in the real world? Well, guess what? When you turn in a theodolite, you never turn a left angle. And which one do they say is the correct angle? Left angle. You turn a right angle. You always turn right angles. Okay? Now, they say, the manufacturers say, it doesn't matter. But when you have one worked on, they say, try to go with either all left angles or all right angles. Don't switch. But, you know, in other words, they tell you the exact opposite. If you're standing there, which is negative 75? Is that a right angle or a left angle? It's a right angle. Okay? But they tell you it's negative in academia, and in the real world, that's what you're supposed to turn. So, go figure. Anyway, I like to pick these little things out because some of you will go on a construction site in the future. Some of you, I'd say all of you. And you got to realize that academia lacks in some areas. Okay? Negative 800. So again, we know it's this way. Well, I guess I'm not going to write anymore today. My computer, okay, there it goes. Negative 800. So negative 800 is going to be this direction. Okay? So let's do it this way. 800 divided by 360. 2 point what? It's 2, isn't it? Yeah. 2 point something. So what's 2 times 360?
120.
Well, for some reason my pen is not working. What'd you say? 220? What is it? 720, 800 minus 720 is equal to what?
80.
Negative 80. Okay, so this one is negative 80. So negative 80 would be down here. Negative 80 is right there. Therefore, your reference, the other angle is what? 2 what? 80. 280? So I don't know which one they want. But I would say the negative 80 since they were asking in the negative direction. Negative 80 would be your reference angle. Those are, you know, you'll see those in the homework. Let's see if we know what we're doing. I think we do. Okay, they wanted the other one, 280, which we always reference both. But in this case, they wanted the reference angles, not the negative. They didn't want the negative 80, they wanted the 280. Capiche? Just like here, I told you that the 285, they want the reference angle, the positive reference angle. Anybody got a question on those? Okay, here's where we get into the radians. Okay, this R and this R and this R are all what? Equal. That's called radian. Do you ever use them? Hail to the no. How do we use them? Because they're in the formulas, that's why. Okay? Academia. Nobody ever uses radians in the real world. So, okay, here's your conversion. I told you about this. I can't move this. There is your conversion. Now, it basically means that if you want to change from degrees, you multiply by pi over 180. And I'll go ahead and write that down for you. I think I already wrote it down for you one time. But if you want to change from degrees to radians, from degrees to radians, you multiply by 180, pi over 180. If you want to go from radians to degrees, you multiply by 180 over what? Pi. Always remember, you have to cancel the unit you don't want. You have to cancel the unit you don't want. So if I don't want the degree, I got to cancel with the degree on the bottom. If I don't want the radians, which is pi, I'll have to cancel the pi with the pi being on the bottom. And that's probably what they're going to get into on the next slide. Multiply a degree measure by pi over 180, simplify. Okay, I just showed y'all that. There you go. Go to it. So 45 degrees, these are test questions. And there's 3 of them there, and don't doubt there will be 3 on the test. It's important. Not because of the real world, because of academia. 45 degrees over 1. So I've got to multiply by what? What do I want to go away? I want the degree to go away, so I'm going to multiply by degrees on the bottom, and that means the 180 goes where? On the bottom. Now you can memorize or you can think. Y'all know the good thing about telling the truth? Anybody tell me the good thing about telling the truth?
You don't have to keep up with lies.
You don't have to keep up with the lies. Okay? A lot of people say, what's that got to do with this? Well, you can memorize it, or you can just think. And sometimes thinking is easier than memorizing. If you just think, I need to get rid of the degrees, then I got to have 180 on the bottom. If I want to get rid of the pi, I need to have pi on the bottom. That's all you got to remember. Same thing with the unit circle. I showed people how to remember the unit circle, and they just drop their jaw because they've been taught to memorize the unit circle. I don't teach people to memorize it. So the 180 goes out, and you're left with 45 pi over 180 and reduce if needed. I'm not going to get into reducing. Okay? Now, this negative 270, what is negative 270? Positive what? Positive 90. So I'm going to, and I don't care which one you do. 90 degrees, so that's 90 degrees over 1 multiplied by 180 on the bottom. Pi, 180s cancel, that's pi over what? Pi over 2. And what they're trying to get y'all to do is see the parts of the unit circle. That's what they're leading up to. Now this one, you're just going to do it on a calculator. Okay? This is 249.8 degrees over 1 multiplied by pi over what? So you're going to take 249.8 divide it by 180 and then put a pi beside it. I'm not going to do that, but that's your answer. Now again, I don't know how many of you have had this. I don't know how many of you have had it and haven't had it. So, believe you me, all of us are going to get on the same sheet of music by the time we get to Unit 2.
For B, we get it wrong if we put the negative.
I wouldn't mark it wrong, but they might mark it wrong because academia wants the positive. Okay? So, you might want to stay with the positive. I may get it wrong, but I think that's what they want. Let's see, did I get that one right? Okay, I didn't reduce that one, so 3 pi, okay, see, they want the negative in this one. I thought they'd want the positive, but pi over 2, 3 pi over 2, negative 270. No, that's wrong. Negative 270 is 90 degrees. 90 degrees is not, that's wrong. Negative 3 pi over 2 is not correct. It should be 3 pi over 2, positive 270. I think that's somebody messed up there. Okay, the answer is pi over 2. That's the answer. That's incorrect. Okay, somebody take 249.8 and divide by 180. What do you get?
1.4.
What?
1.4. I got 4.
They didn't do the pi. Multiply that by pi. Sorry.
That's right.
4.3. Did you get 4.3? They multiplied by pi. I didn't. Okay. The only thing you need to make a note of here is this is not correct. So why is that? Because you're not going to see a unit circle with 3 pi over 2 up here. You see what I'm saying? You're not going to see a unit circle with 3 pi over 2 right here. You've got to change it to, that's pi over 2. Negative 270 degrees is this way. Okay? Negative 3 pi over 2 is saying that you're going to have, I don't like this. It's right, but it's wrong. Okay? I don't like this. So you won't see one like this on a test. Because that's like telling you to remember the unit circle differently, and I don't want to do that right now. So I'm not going to, let's just kind of X through this one. But I don't want you to remember this as negative 3 pi over 2. I don't want you to do that. Not right now. I hope you understand what I'm talking about. If you don't, then I'm sorry. Okay, and I think that's what they're doing there, and you can change it to radians, but it needs to be in what mode? Radian mode. Okay. Now, let's do this one. Now this, I want you to do this by hand. Why? Because this is how you remember your unit circle. From changing from degrees to radians and radians to degrees, this is how you learn the first unit of trig. So I'm going to multiply this by what? 180 over what? Pi. Pi's cancel, and I get 9 times 180 over 4. And of course, I'm going to try to reduce. So I know 4 will go into 180. 4 will go in there 4 times and leave 45, right? So 9 times 45. 9 times 5 is what? 45. Bring 4. 9 times 4 is what? I'm sorry, what?
36.
Shouldn't be more than that.
9 times 4?
Okay, it should be.
9 times 40 is 360.
No. I'm trying to, why is it doing? Is there anything that can be, 4 will go in there, how many times? 45? Okay, I guess it's 365. How much is it? What's 9 times 45? 405. Usually they're under 360 degrees. Okay, I'm thinking of the unit circle. So if you change 9 pi over 4 to degrees, it'd be 405 degrees. Negative, multiply by 180 over pi. Pi's cancel. 5 times 180 over 6. How many times will 6 go into 180? Negative 150 degrees. Now, 4.25 radians, they probably want you to do it with the calculator because of the pi. Let's see what they want to make sure. 405, 150, negative 150. They multiplied by 180 over pi. Okay, I want to make sure they wasn't using the calculator. And that's, of course, gives you 243.5 degrees. But as a general rule, you multiply by 180 over pi. Those are 2 more test questions. And they show you how to use the calculator there. Make sure that your calculator is in degree mode when you're going from radians to degrees. There she is. Now I'm going to show you how to learn it without using a calculator. And I guarantee you, so I already know it. Well, if you already know it, that's great. Knock yourself out, okay? Stay at home. I'm not here teaching the students that know it. I'm here teaching the students that don't know it, okay? Now, how do you learn it? And learn it that you don't have to, what do you call it? Memorize it. Well, this is how you learn it. Take your handy dandy circle maker and you make a VA circle. Oh my gosh, I suck. Frosty snowman. There we go. And we take our handy dandy line maker. Now, of course, you can do this however you want to. You could do this by going to Google and Googling the unit circle and copying it. You can do it by drawing this by hand 5 or 6 times. You can, that's crooked. You can memorize it. I don't care, okay? I do care, but I don't care, all right? I care because I want you to learn it. Where is my... That's big. That's the problem. Okay, is that better? Oh, be quiet. All right, so the first thing we're going to do is we're going to label it. Okay, so this is 0, and it's also 360. It's also 0 and what? 2 pi. So that means that this guy over here is pi or 180 degrees. This one up here is 90 degrees or pi over 2. This one right here is 270 degrees or 3 pi over 2. Now there's 3 angles in trigonometry that you need to know. Does anybody know those 3 angles? One of them's 45.
60.
One of them's 30. And the other one is what? 60. 60, 45, and 30. Now change every one of those to radians. Change every one of them to radians. That means you got to change 180 over pi, right? Or pi over 180. So multiply by pi over 180. Multiply by pi over 180. Multiply by pi over 180. And that's going to give you, what is this? Pi over what? Pi over 3. It's a miracle. What is this? Pi over what? Pi over 4. It's a miracle. 3 pi over 180 be pi over what? I didn't memorize a dang thing. How you do the rest of it, Hubert? Well, it's easy. Extend this one down here. Why does it mess up when I do dots? I mean, is it that big of a deal? Or I think I was reinventing the wheel. Okay, so what is this angle? That's 38, 30. This is 30. What's 30 plus 180? What's 180 plus 45? And what's 180 plus 60? Or you could take 270 minus 30. What is it? Now change those into what? Radians. So multiply by pi 180. Multiply by pi over 180. Multiply by pi over what? 180. So what's 210 divided by, it's 21 divided by 18. 7 pi over 6. Somebody check me. 7 pi over 6. 225 over 180. That's going to be what? What does that come out to be? 5 pi over 4 it should be, shouldn't it? And 240 gives you 24 over 18, which 8 pi over 6 or 4 pi over 3. Somebody check me. Look over there, I just did that side and I didn't memorize nothing. What do you do now, Hubert? Well, go over here. Draw. There's your 60 degrees. There's your 45 degrees. There's your 30 degrees. What's 180 minus 30? It's a miracle. What's 90 plus 45? What's 90 plus 60? Or you could do 180 minus 60. What is it? Or 90 plus 30. Now change those to pi over 180. Pi over 180. Pi over 180. Okay, that's 12 over 18, which is what? 4 pi over 6? Or 2 pi over 3? Somebody check me. 135 over 80. Somebody divide that for me. 3 pi over 4. And 180, that's going to be 15 over 18, which is 5 pi over 6. All right, you do this one. You do the fourth quadrant. I guarantee you there's somebody in this room or the 4 rooms that are going, I never knew you could do it without memorizing. Anybody want to confess? What was I going to say? Pendleton, settle down. Pendleton, are all your classes like this? Y'all don't talk, y'all just sit there?
Yes.
Yeah.
Normally they don't like us to talk. They like us to listen.
Well, I'm not that way.
Learning curve. We're trying.
Okay, well, at least you're trying. Anybody ever had trig before and you were told to memorize this thing?
Yes.
You don't have to memorize it. You just have to think. Let's do it. What is 360 minus 30? It's a miracle. What is 270 plus 45 or 360 minus 45? Well, if my pen would write, my battery is going dead. And what is 270 plus 30? 300. Change all these pi over 180, pi over 180, pi over 180. Now the easy ones are outside. The 45 you might have to do in your calculator because it's aggravating. But 330, that's 33, that's dang old 11 pi over 6, isn't it? 11 pi over 6. 300, the zeros, that's what? 10 pi, not 10 pi. 5 pi over 3? Check me. 5 pi over 3. And what's 45, or which one's this one? What's this one?
7 pi over 4.
7 pi over 4. Now, I'm going to show you a trick to learn in the war. What does all the 45 degrees have in common? Over 4. Over 4. What does all the 30s have in common? over 6. 30 is over here 6. And then what does all the 60s have in common? Some of y'all might see that pattern. Now I'm going to show you another trick I learned in the war. This, when you're talking about the unit circle, the cosine comes what? First. And the sine comes second. This is your coordinate. You got a coordinate. I want you to think, if I'm going to go right here and get this coordinate, I'm going to go in the x direction, I'm going 1, and in the y direction, I'm going 0. So that's going to be 1 and 0. Sorry, my bad. And you can fill it out. We haven't gotten to this yet. That's going to be 0 and 1. No, 1 and 0. I don't know why I said that twice. 1 and 0. Okay, what about up here? Cosine and sine. Well, that's going to be 0 in the x direction, so that's going to be 0, and 1 in the y direction. What about this one? -1 and what? 0. 0 in the y direction. What about this one? 0, -1. And then, of course, you can do your special angles, but we can't do those yet because I haven't taught you Oscar had a hunk of apple. I'm going to go into Oscar had a hunk of apple here in just a minute. I'm sorry, Sokotoa. I had this one chick. Oh, God. Ugh. About the second or third semester, I taught trig, and she was from Pennsylvania. In our first day of class, we went around the room, and she said, I'm from Pennsylvania, and I do not speak with an accent. I speak perfect English. Everybody else from all over the country speaks with an accent, but I'm from Pennsylvania. Of course, everybody hated her guts the first day. But every time I would say something, she would go, Mr. McClure, I do not understand what you're saying. She had this Willie Nelson thing going on. You know? She is the one that's why I do not pronounce OIL. Because of the FOIL, and she said, FOIL. And she said it perfectly. So anyway, I'm going into the trig, and I'm going into the Oscar had an Uncle Apple, and she said, Mr. McClure, I do not understand what you're talking about. I said, Oscar had a hunk of apple. Opposite. Oh, you mean Sakatoa. I looked at her like, shut the hell up. She wanted me to say Sakatoa instead of Oscar had a hunk of apple. Okay? That right there is in a synopsis why I'm divorced. Okay? Because of people like that. I cannot take people like that. You know damn well what I'm talking about when I say Oscar had a hunk of apple, but since it's not the way you were brought up, or since you've got to make sure you interject that you were raised different, or that you were brought up differently, or that some teacher taught you a different method, just shut up. Anyway, those of you, Sakatoa, okay? I don't teach Sakatoa. I teach Oscar had a hunk of apple. It's the same thing. Okay? So we got that out of the way now. So somebody's going to say, shut up, life. Anyway, y'all know what kind of people I'm talking about, right? My father had a term for them. My father called them yuck people. You know, like yuck. Y-U-C-K. I don't want anybody to get that. He called them yuck people. He said they had no life and they were real depressed. And I can understand that. Somebody that splits frog hairs, there's no reason for it. Oh, I do not understand what you're saying, Mr. McClure. I was brought up Sakatoa. Okay, nobody knows what I'm talking about. Okay.
You might need therapy.
What?
It seems like there's a lot of just pent up anger.
Yeah, about 25 years worth. When you're a teacher and you go through these type, They do get on your nerves. Just like the student. I need a question. Okay. I got it. It's right 2.4. Okay, send it to me. And he writes an email. I mean, what would you do? I mean, maybe I just need a drink. Maybe that's it. Okay. All right. There we go. And that's where you get your numbers from. Now, there are the special angles. The special angles, we're going to go into those with Sokotoa. Now I'm saying Sokotoa. Yeah. And they're probably going to go into it. But here, they're not going to go into it yet. Here is the formula for the arc length. Okay, what is an arc length? Well, it's the length of the arc, or the curve. Here is a circle. Here is the radius. The radius is the same. R is equal to R. If you drew a straight line from this point to this point, that is called a chord. Okay? If you're going into engineering in the future, a horizontal curve, that is called a chord. All right? Outside of that is called the curve. In the real world, it's called a horizontal curve. In academia, it's called the arc, or the arc length. Okay? Now, I got a question to ask you. Will the arc curve always be longer or shorter than the chord? Good. It will always be longer. The curve will always be the longest between the curve and the chord. Because what is the shortest distance between 2 points? A straight line. Straight line will always be less than a curve. Okay? So, and this is how you find the length of a curve. Wait till you see it in traffic engineering where you do a horizontal curve. They take that and they make it into a half-a-page formula. Just that right there. That two things right there, they turn it into a huge formula. But anyway, I don't know, I don't see why they have to do that, but they do. So anytime you are doing, you have to have theta, which is your angle, and R, which is your radius. Yeah, actually, when you said that I had a lot of anger issues, that is why I do not pronounce OIL and FOIL to this day. That happened like 2 years after that's why I don't do it. Anyway, here we go. A circle has a radius. This is not supposed to be showing all that. Hold on. Okay, it's not supposed to show it. I don't know why it's showing it, but maybe it's just an example. A circle has a radius of 18.2 centimeters. A horizontal curve, a radius will be 3.2 miles, or 5.6 miles. Find the length S of an arc intersected by a central angle, theta, having each of the following measures. 3 pi over 8. 3 pi over 8 radians is your angle. So multiply by 3 pi over 8 over the multiply by the radius. That's it. When they're laying out a road or a subdivision or a cul-de-sac, what does the curve length have to be? Does anybody know? A minimum. Minimum of a fire truck, transfer truck, or school bus, based on where you're building the road or the curve or the cul-de-sac. In a residential area, it would be the length of a what? School bus or a fire truck. So if you built a cul-de-sac, it would have to be, the curve length would have to be more than 50 feet. So, see, that's some of the stuff that you have to get into when you're talking about curve length. Because I'm going to tell you something. You don't have to do a little circle of 18.2 when you're in the real world. I mean, that's not applicable. But the principle is the same. So you would set this equal to 50 feet. And if you had a radius of 150 feet, then you could find the angle that you turn to get that 50-foot radius. See what I'm saying? Or 50-foot length. So that's a good problem right there, and that is the problem that shows you how to do those two problems that we pulled up in the homework. But you got to know here we go. A circle has a radius of 18.2. Find the length of an arc intercepted at 144 degrees. Well, the first thing you got to do is change that to what? Radians. So pretty much since it's words, you probably quit before you even start, right? Just go to the next problem. Try to find an easy one. Easily, how's y'all's weekend? I'll talk to Easily and Oconee. How was y'all's weekend, Easily and Oconee?
I did homework.
Okay.
I worked all weekend.
That's
played
not
golf.
depressing.
I went
Y'all
shopping
are actually,
Friday.
Oconee and Easily, y'all are pretty depressing.
Yep.
Yeah. Need Napoleon Dynamite in here. Yep. You know what? When Napoleon Dynamite, I was one of those that just laughed through the whole thing. You either sit there and look at it like, what the hell is this? Or you laugh. I laughed, okay? I still laugh. I think they should have had Napoleon goes on his first date. Napoleon graduates high school. Napoleon goes to college. I thought they should have had a whole series. You know how much it cost to make that movie? It was like $10,000. Yeah. And it made millions. I love it. Hilarious. Especially when he's jumping that ramp with that. That's hilarious. Or when he gets beat up at the lockers, that's hilarious. Because you know why the people that like it, you know why they like it? Because there was always a Napoleon Dynamite at your high school. I don't care where you went to high school, there was always a Napoleon Dynamite. And there was always a Pedro. One of the two, they were always there. Okay, I'll shut up. Trying to get y'all to interact. But Easley and Oconee, y'all pretty much depressing, so I'm not going to ask y'all anything else. Is that what it is, Pendleton? Are y'all just depressed? Is that what it is?
Yep.
Yeah.
Yeah, you have to go to math class and you have to talk to your teacher, so that's pretty depressing, isn't it? Okay, got one laugh. Leaned on a pickle. Conditioned not to talk in class. Multiplied by pi over 180. What does that give us? Just give me a decimal in pi. What does it come out to be? 4 over 5 pi? 4 pi over 5? Is that what you got? I don't know what's going on with this picture. 4 pi over 5 multiplied by 18.2. And somebody multiply that out for me, round it to 2 digits. What do you get? 4 times pi times 18.2 divided by 5. What do you get? 45 point what?
7.4.
Thank you. And that's how you do it. Now, don't forget, it's a unit of measurement. Do I care? No. Will there be some science teacher that will mark your problem wrong because you didn't put centimeters on it? Yes. Make sure you write centimeters down there. And let's check it to make sure we know what we're doing. There you go. How are we feeling? And you see that problem that y'all are sending is not that complicated. You just didn't what? You didn't know. I think that's pretty much it. Okay, we got to do I'm not going to do that now. That's where we get into using latitudes. Yeah, we're going to wait to do those. Yeah, we're going to wait on these because that's finding this. Okay, we'll wait on that. Okay, now you're able to do a few more questions, and then we'll finish up. We'll finish up this section, and you can go ahead and start work area. We're going to do area next, and that'll finish out 5.1 or 9.1, wherever we are. So if you want to go ahead and start working, go ahead and write down the area formula. Go ahead and write that down because it's the same concept, only you're not multiplying by the radius, you're multiplying by the radius squared, and you're getting square units. This is where, if you're putting in a highway, and you've got to take somebody's land, or buy somebody's land, you got to figure up the acreage. That's where this formula is derived, or the derivation for that formula is derived from this formula. Okay? How many people we got in Pendleton? Somebody count for me so we can see if everybody's there or not.
11.
11.